Hello everyone. Today I am here to discuss the Mohr circle of case 2. In my last video, I discussed the case 1. And the case 2 is a body is subjected to two mutually perpendicular unlike stresses of unequal intensities. On my last video, I discussed like stresses of unequal intensities. Now today I am going to discuss unlike stresses of unequal intensities. So this is a rectangular bar A, B, C, D. These are the stresses acting on the bar at faces A, B, C, D. Sigma X, the tensile stress, and sigma Y is the compressive stress acting on the body. Now this is the oblique plane CE, which makes an angle theta with the plane of the sigma X, or we can say with BC. We will find out the normal stress, tangential stress, principal stresses on the oblique plane. So sigma X is called the major tensile stress and sigma Y is the minor tensile stress. And the condition here I have taken sigma X is greater than sigma Y in magnitude. So first of all, we have to do the scaling. So stress is equal to in terms of centimeter or millimeter. Then you can find out the sigma X stress and sigma Y stress in terms of centimeter. Now, how to draw this circle? Okay, let me explain. First, we have to take a point A. So I have taken a point A. Again, the convention is we will take the right side of A as positive and left side of A as negative. And then draw a horizontal line AB on the right side of A. On the right side of A, I am drawing a line AB such that AB is equal to sigma X. Now sigma X I have drawn on the right side because sigma X is a tensile stress, positive stress. So I have drawn on the right side of the point A. So AB is equal to sigma X. Now second point, since sigma Y is compressive, hence draw a line AC, on the left side of A such that AC is equal to sigma Y. Now take BC as diameter and O as center. So O is the center. Draw a circle of radius OB or OC. So this is the circle with center O having radius OC and OB. Now draw through O, draw a line OE such that OE makes an angle 2 theta with OB. So this is the OE line which makes an angle 2 theta with the line OB. Now from the point E, draw a perpendicular ED on the line AB. So I have drawn a perpendicular line ED on AB. Now join AE. So AE I have joined. Now length of AD will give you the normal stress on the oblique plane. Length of AD, this length, will give you the normal stress acting on the oblique plane. And the length ED will give you the tangential stress on the oblique plane. Now length AE, this length AE will give you the resultant stress on the oblique plane. Now, major principal stress and minor principal stress. Again, what is principal stress? Principal stress is the normal stress acting on the principal plane. Now, what is principal plane? Principal plane is the plane at which the shear stress is 0. Now, look at this diagram. The shear stress is ED. ED is a perpendicular line which is given as shear stress, and the value of ED will be 0 at the point B and at the point C. So these two planes are the principal plane. So we can say AB, the length AB is the major principal stress because AB is the normal stress acting on the principal plane. So AB is the major principal stress and AC is the minor principal stress. Now what is the radius of the Mohr circle here? Radius of the Mohr circle here, because AB is the sigma x and AC is the sigma y, and the total BC becomes sigma x plus sigma y. And we have taken the diameter as BC, so it is sigma x plus sigma y divided by 2. So we can get maximum shear stress is equal to radius of Mohr circle. Maximum shear stress is equal to radius of Mohr circle, because this is the shear stress and it will be maximum at this point. It will be maximum at this point passing through the center O, and this is the radius. So and this is the maximum shear stress, and it is sigma x plus sigma y by 2. So maximum shear stress, principal shear stress major, principal shear stress minor, then the normal stress on the oblique plane AD, length will come in centimeter. Then you have to convert it into Newton per centimeter square or Newton per millimeter square, that is in terms of stress. So with this I have completed the second case also. Then my next video I will show you the case 3.